Hello everyone. Today we're going to go over section 19.1, acid and base, characteristics of acid and base. So we're going to physical properties, identify physical properties and classify acid, base, and neutral, acidic, basic, and neutral. And we're going to compare Arrhenius, Bronsted acid bases. Um, these are some of the terms. Now, acid, some of the characteristics are it tastes sour, um, and you find it as, for example, citrus fruits have citric acid. Bases are taste bitter and feel slippery. An example would be sodium hydroxide, like soap, and they're also there's too strong. They can unclog your drains. You can burn your hands. Let's see. They also, milk of magnesia is also a base and it neutralizes the stomach acid. And because acids and bases ionize or dissolve in water, they're good conductors. An example would be hydrochloric acid. Now, the strength makes a difference between how strong or it glows. And in nature, you find them in limestones, calcium carbonate. And there are two videos here, one that shows the litmus test and one that shows that acids reacts with magnesium and zinc reacts with hydrochloric acid and give off hydrogen. So you can watch these. You have the PowerPoint. Now, we're going to go over Arrhenius first. Arrhenius model.
Arrhenius model, a model of acids and bases, states that an acid is a substance that contains hydrogen and ionizes to produce hydrogen ions in aqueous solution, and a base is a substance that contains a hydroxide group and dissociates to produce a hydroxide ion in aqueous solution.
Okay, exactly that. So hydrochloric acid will break down into a hydrogen ion and Cl minus, and NaOH will ionize and give sodium and hydroxide ion. And we have a few examples or practice problems. Write balance formulas. Write balance formula equation for the reactions below. So we have the first one is magnesium and nitric acid, and magnesium is Mg, nitric acid is hydrogen plus NO3, and then we know that magnesium has +2, nitrate has negative crisscross, magnesium gets 1 and NO3 gets 2, so MgNO3, 2 in parentheses, and then hydrogen is given off. And then to balance, you have 2 NO3, so we put 2 here in front. So now the hydrogen is balanced and NO3 is balanced. Aluminum and sulfuric acid, H2SO4, that's sulfuric acid plus aluminum. Now aluminum is +3, sulfate is -2, crisscross, and then hydrogen is given off. The focus here is not really on how to do the crisscross anymore, but that the hydrogen is given off. And then we balance it. There are 2 aluminum here and 3 SO4, so we multiply this one by 3. Now 6 hydrogen, so multiply this one by 3. So 3H2. Calcium carbonate, CaCO3, and hydrobromic acid, HBr, will give calcium, bromide, water, and CO2. So once you see CO3 here, then water and CO2 is given off. Potassium hydrogen carbonate, potassium hydrogen carbonate, and hydrochloric acid, HCl. Now, potassium goes to Cl, and then water and CO2 is given off because of the CO3. Now, Bronsted. Bronsted is acid, oh here,
Bronsted-Lowry model. A model of acids and bases in which an acid is a hydrogen ion donor and a base is a hydrogen ion acceptor.
Okay, so now we keep track which one is going to donate the hydrogen and which one will accept. So they're both just in a relationship giving and taking hydrogen. So let's see. Now once the one gains a hydrogen.
Conjugate acid. The species produced when a base accepts a hydrogen ion from an acid.
Okay, so when a base accepts hydrogen, then it's called conjugate. It wasn't an acid by itself, but it was donated. It was accepted in a reaction. So accepting a hydrogen. And I'm going to give you an example right now. NH3 is a base. And now here, if you keep track, it gained a hydrogen here. So that means water gave it a hydrogen and became NH4. So water is an acid. It lost the hydrogen. So whatever is left is the conjugate. It's called the conjugate base. Now, we start here because this one accepted a hydrogen, so it's a base. And the one that gained, now it become NH4, that's my conjugate acid. Now water is a perfect amphoteric.
Amphoteric describes water and other substances that can act as both acids and bases.
Okay, whatever acts as acid or base, it's called amphoteric. It's just another term. Now conjugate base.
Conjugate base. The species produced when an acid donates a hydrogen ion to a base.
Okay, so for example, hydrogen fluoride is an acid, but then now it's going to donate whatever is left over after it donates its conjugate base, and this one is the base, water is the base, and accepted, after it accepted, then that's my conjugate acid. So we know that H is an acid, hydrogen fluoride is an acid, so that means water has to be the base. And then we just keep track of fluorine, that's the conjugate base, and from water it gains, so it becomes conjugate acid. And if you just want to look at the models, hydrogen fluoride donates a hydrogen. Once it donates, it's an acid, and accepts, that's the base. And whatever left of the HF after it donates, that's my conjugate base, and whatever the H3 would be my conjugate acid. Okay, let's do some examples. Okay, so here OH minus becomes H2, so it gained. So that means NH4 must be my acid. So acid, after it loses a hydrogen, becomes a conjugate base, and OH, after it gains, it becomes a conjugate acid. Okay, we know for water here it gained one hydrogen. That means it's a base. HBr is my acid, and after it loses a hydrogen, it's a conjugate base. And then the water is the base, and after it gains a hydrogen, it's the conjugate acid. Sorry, I went through that fast. Okay, the next one is CO3 and water. Now, there's no hydrogen here, so water must be my acid. And after it loses a hydrogen, it becomes OH minus, and that's a conjugate base. Now, CO3 is my base, and after it gains a hydrogen, it becomes conjugate acid. HSO4, that's my acid, and when it loses a hydrogen, it becomes conjugate base. Water is a base, and when it gains a hydrogen, it becomes a conjugate acid. And that's today's video. I hope that helps. Have a good day, everyone. Thank you.